Hello, welcome to the product demonstration of NLX. It's a natural language parsing tool based on a domain-specific language and convert natural language text into a model. My name is Felix Schaller and I will now guide you through the features of this tool. The tool is a little bit older. It started in development 2018, so it began its development before ChatGPT. I will later say something to the difference between NLX and ChatGPT and those tools where ChatGPT is using large language models, but here we are aiming to create direct cognitive models which have a constraint between the different entities in the conversation of the language, thereby creates semantic logic. I will now guide you through the project. First of all, we have a content, so we give a little brief overview of NLX and then the framework of NLX below, what it consists. And I already stated that in the past, natural language was started around. So natural language exists along. I don't want to give a comprehensive presentation about it because most things are now, especially after ChatGPT was skyrocketing through the IT business and now creates a total new interaction between computer and the user. But NLX wants to go beyond this capabilities because current nowadays large language models are mostly based on bias principle, which try to mimic what's already said in the internet. The problem is that there is real logical queries are hard to pass to the machine because there's no logic model in the background which can understand what the human is saying, but tries to mimic what's already said in the internet by parsing a lot of content and thereby combining the nearest probability what could be said, and by iterative improvement through machine learning, the content improves, but still large language models do not know what's actually said or the content, the cognitive logic that is behind the natural language expressions. This cannot be understood by ChatGPT and other large language models because there's a logical model missing. And the aim of NLX is to provide such a logical model. It can create logical constraints and by that resolve the content by creating relationships between those different entities. You build up a logical model. And that's the difference between large language models, which try to adopt to the content they learned, and real logic. All right, now we go to the natural language parsing pipeline, how it is set up. So first of all, we have a grammar that is tokenizing the textual content into a document object model. And by this document object model, you then can resolve a grammar tree of the sentences and thereby resolve who is the subject and who is the object, which is quite common in natural language processing, such resolution of actors and that's all then resolved in a dependency. Here we have a text segment of ISO standards from the automotive industry. And this text getting parsed into a document object model, which you can see here. And here, this is the grammar tree resolver, which tries to resolve the structure of a sentence by resolving who's the subject and the object and the predicates and so on. And this is a trained model that can be trained by this grammar trainer here. Here again, you can see that in an overview, this is the editor. We have also a property sheet, a property viewer, which can again print out some properties of all the objects, the tokens we parsed. So we can also have a little bit of a debug view, which it tells us more about the features of each of those word tokens. And here we have the model of the document, which is getting resolved in all the tokens. So thereby we can parse this document and the content within. In the background is also our dictionary running, so we can by that classify the word, whether it's a noun, a verb or adjective, and all the other word classes we have in the English grammar. So currently it's also only running in English language because English is in its structure much easier than other language like German or maybe French. So thereby not making the things too complicated in the beginning and make also the resolution of the grammar more easy than in other languages. So we now introduce the Xtext framework, which runs below and converts the textual content into a document object model based on a domain-specific language that is capable to read classic textual documents and convert words into tokens, and also other sentence structures are understood by this domain-specific language. For instance, list sentences, tables, and further on. I will introduce later on into all the capabilities this domain-specific language is capable to parse. So you can configure this grammar so it can read text. It's based on a grammar that you start in the beginning that gets converted into an ANTLR model and then later on into an eco model, which then creates all the structure of the document. And this model you can use to parse the content of the document, where we have then a model. First of all, we have a main sentences. This is separated by comma, and then we have sub sentences, which is tokenized in this way. Invisible tokens, white spaces are ignored, but all the other visible tokens are used and thereby converted into that model. These are different types of tokens we have. We have classical words, then we have special IT words with camel case or strings or URLs. We have numeric tokens, we have URLs and emails. We can also use emojis, acronyms, and also ignored strings like multiple dashes or multiple stars in a sequence that gets converted into ignored text or text parts that are not seen as common natural language text. So as I already mentioned, so here we have the structure of the different sentences. So we have sentences, sub-sentences, list sentences, chapter sentences, which indicate a chapter with a starting chapter number, and thereby it's detected as a chapter sentences, and also sentences in brackets, which get handled separately. So inside a sentence, we can have bracket sentences, which can get handled differently. And we have also quotes, which currently are not parsed internally, but just used as a basic string and not getting tokenized any further in the content itself. So it's also can be used for escaping some parts of the text file to not get parsed by the DSL. This is a view of the AppSec syntax tree. So here we have another view of the AppSec syntax tree, which is behind the natural language domain-specific language and which is used to parse the document to a model. So this now would implicate a demo, a live demo of the tool itself. This is done later. Here we have the current state of the development. Meanwhile, the development has gone further, but at the beginning, as I said already, there's a grammar that is used to tokenize text files. And these text files then are converted into a model. And that model is then used to resolve the grammar inside the text and create grammar trees, which then are converted further into a ontology of a entity relationship model. And by this entity relationship model, we can then create real cognitive models. So we can create real cognitive logic, and by this logic, we can express all types of semantics, which then get converted into commands or even software code. That's the aim of the tool. So we convert this ontology into a cognitive model which is capable to resolve the logic and create commands or even produce software code. This is future vision and outlook. Yeah, as I mentioned already, the difference between NLX and large language models. Large language models are based on neural networks which are trained on different samples of text. But as it is with large language models, the problems here is that you have no logic behind this model, and thereby these large language models try to mimic the content of the text they have parsed and reform it into a new shape. But real cognitive models are also not available to large language models because there is a logical model missing which builds all the constraints between the entities and thereby resolve a constrained logic inside the context of the conversation or the text itself. So what's contained in the text, the context needs to be resolved into a model, and this only can be done when you have a model in the background which creates constraints between the entities and thereby formulate a logical constraints between all the involved entities. Such neural networks only try to mimic the content, what is said, but because there is no model underlying, they actually cannot understand what the content is about, but they try to mimic due to many different samples what is said and thereby produce new content. Now I'll give a little bit of a background information about the abstracts, about the dynamic model that is behind the grammar tree. So we have a trained rule set which tries to resolve according to the occurrence of certain word types how the structure of the sentence has to be resolved. I give later a demo how this works. So this is the model, how it looks like in a primitive way. And this is about the demo. There can be also other applications are possible with this domain-specific language. So you could also apply it to logs and thereby parse log files. So you could resolve the content of those log files and assess what has been processed, and this could maybe help in continuous integration to automate continuous integration tasks when there are errors produced. Such log parsers could automate certain self-healing tasks and thereby automate DevOps task. The final goal for this natural language project is to create a tool that is capable to develop commands or even code out of natural language. And this only can happen if you have a certain interactive interface. Because as it is with all natural language text, they are expressed in an abstract way, which is in the first stage not explicit. And so the software will give you a interactive feedback where you have to specify further that the content is resolvable. It's something that is that tries to interact like a classic integrated development environment where you get parts of the sentence underlined and thereby the software tells you where you have to specify further that the content is resolvable. It's not something that is proactively approaching you like this little Clippy agent that was common in the 19th in Microsoft Word. So this kind of agent is very annoying and thereby should be avoided by any case to interact with a client in a proactive way, which is not interactive. So you need some kind of a interactive solution that makes a comfortable user experience possible. These are the links where you can download the current version of the NLX tool. So you can also find publications on ResearchGate, and this project has been published on the Modellierung 2022 in Hamburg and is published on this conference. So you find it in proceedings of the Modellierung 2022 conference where you find this article published. So this is all about the NLX tool. Right now, thank you for joining this video and stay tuned.